Hello, everyone. My name is Mark Wood. I'm the product manager for the Gitaly group here at GitLab. I wanted to make a quick video showcasing the successful proof of concept we have around a feature which could eliminate the need for Git LFS for our customers who need the ability to store large files within Git. For those who are unfamiliar, storing large files in Git can present a series of problems for customers. Git doesn't handle large files all that well, and it can make the repository relatively cumbersome to work with. There's an external solution called Git LFS that requires clients to install a Git LFS product on their machines, and it enables them to store large files within an LFS store, which is effectively external storage to Git itself. This does require some configuration, and it's notoriously difficult to set up. We've had a lot of customers discuss that this is a pain point for their organizations adopting it. There's also some risks because migrating away from a Git LFS solution does require the rewriting of commit history, which can be complex and sometimes dangerous. Finally, users really just want a native Git solution that works. What we on the Gitaly team have embarked to do is create a solution that sort of encompasses those values. We started out with this concept of a promisor remote, which in Git means that the file can be stored not on the primary Gitaly node or on the primary Git server, but in an external location pointed to by the Git server. It's a similar concept to LFS, but it's handled natively within Git. We then can offload blobs or files, if you will, to these external locations, which can also be stored in object storage. What this enables us to do is create a filter, which could then theoretically store all files over a certain size on object storage. This is preferable to LFS because from a client perspective, there's no change. Our goal is to create a client-side experience where a client can simply pull or clone a repository. They get all of their files, just some of them are coming from external object storage. The final thing is that this will all be taken care of within Gitaly with a few administrator settings, i.e. what do they want to offload to object storage, and the rest of it is just transparent to the users. So why does this help us here at GitLab, and how does this help our customers? Many industries have been requesting better support for large files, gaming industry in particular, and as the prevalence of AI expands and we find customers wanting to store large models in Git, large file support is kind of crucial. For all of our SaaS offerings, this has the potential to offload certain blobs to object storage, which is far cheaper for us to store data. And we can filter what gets offloaded to object storage by file size, by blob size, by blob age. There's lots of potential here where we could fine-tune these settings on our SaaS offering to allow for better storage for files that are either not used very frequently or are big, and it would save cost. And the other big thing is we see a lot of customers complain about the spikiness of Git traffic. When they have large monorepos and somebody performs a clone or a pull, they see processor utilization spikes, they see traffic spikes on their primary Gitaly node. And we see the same thing in our SaaS offering, though to a lesser degree because we have much more powerful and much larger sort of implementations. What this forces a lot of our self-managed customers to do is actually utilize a larger referencer architecture to account for the spikiness of the traffic. If larger blobs were to be offloaded to object storage, this would reduce their infrastructure cost. They're storing less data in fast storage and more data in object storage. It would also offload that processing and offload that transfer, which would reduce the overall spikiness of the traffic. This could enable them to use a more right-sized architecture for their installation and could save infrastructure costs. For those interested in seeing the proof of concept that we've done so far, please stick around. I'm going to attach that demo we did at the end of this video. You can watch members of the Gitaly engineering team walk through a rough proof of concept for this feature. And now that we know it's feasible, we're actually starting to do some planning around this. Our goal is to get an architectural blueprint in place during Q3 and begin implementation within the Gitaly code base in Q4. Thank you so much. I appreciate you watching this and sharing this with other people within the organization. Obviously, if there are any questions, please reach out to the Gitaly channel or reach out to myself. I'd love to talk through this with you. Thank you so much.
All right, take it away, Eric.
Sure. So let me share my screen. Yeah. Am I sharing now? Am I sharing right now?
Yes, it works.
Yep,
Oh,
can
cool.
see it.
Thank you. Yeah. So on the right side here, this is a test instance of a GitLab server. So where I have already set up all the requirement on how to enable this offloading features. And on the left, I'm gonna have a quick demo on how this will affect the size and of the repo and how we can do it. So first of all, I SSH'd into our test demo VM, and then I'm gonna first is to watch the size of this demo repo. So the size of the repo is around 1.2 gigabytes, and on this window is showing whether we are missing any object from the repo. So right now this is a healthy repo, so nothing is missing, and we have 1.2 gigabytes. And on these two windows, I'm gonna just tailing the logs of Gitaly and the Git remote helper. Okay, so right now I'll start the offloading. So on the demo repo, so I'm just gonna go to the general configuration section, and I'm just gonna run a housekeeping job. So after the housekeeping job kick out, so what it is essentially doing is that on the backend, it will according to the criteria we want to filter. So it will filter out all the objects we want to upload, and then uploading those objects to the remote GCP bucket, and then do a repack to delete all those objects from our repo. And okay, so after the deletion, you will see the repo size shrink from 1.2 gigabyte to 17 megabyte. And of course, we are missing three objects because we already offloaded that into the cloud bucket. So after this, basically the offloading is done. And I'll do also do a clone on it's like mimic what will happen on the client side. So I'll remove what I did this morning and then do a clone. So we have to export a few environment variables. I'm expecting as the feature goes to mature, all those environment variables will go away. So so at the very end, so the user will just give a normal clone. So you will have it out, but right now it is what it is right now. So after I do a clone, so the client will go to Gitaly and fetch all the existing objects down. And then it will see, okay, so there are some missing ones. So it will then go to the use the Git remote helper and try to fetch all those missing objects from the cloud bucket. So this is a log of the remote helper. You can see that it's start exporting all those three missing objects directly from the bucket to the client. So it will take some time because the size of those blobs is relatively large. So actually this morning, it's experiencing some network issues, and the streaming session might time out. So, but yeah, eventually all those blobs on the bucket will be pulled off and put it into the client.
So Eric, how did the server decide which blobs to offload to object storage?
So we have to configure a filter. So let me show you on this window. Oh, I'm not sure what's went wrong here. Is save that. I have some trouble trying to SSH to the server. So basically we are parsing. This is on the client side, but on the server side. So right now we are parsing a immutable variables to Gitaly server itself, and which contains the size we want to filter, and in the Gitaly server. So Gitaly taking this value, and it will convert it to a filter, and use that filter to filter out so what object we want to offload. So I guess once all this finished, so probably I can show it.
So in theory, this could be utilized to offload or filter based on size, file type. There's other options there as well beyond size. But I mean, obviously the most prevalent is probably size for people. But for instance, if they wanted to offload specific file types, like in a game studio, they sometimes have graphic files or background files that are quite large. They could actually filter by type, and those could be offloaded specifically if requested.
Yes, in theory it can be, and this filter thing, I guess, correct me, Christian. So Git already have a format on how we define those filters, right?
Yeah, right.
Okay, so it's using standard Git filter syntax.
Yes.
That's excellent. Thank you.
And another thing that this could be useful for is, we did analysis on our whole entire .com fleet, and we noticed tons of projects that like are never accessed. And so you could take those projects that are stale and just offload all the blobs. And to the application, nothing has changed. We just move the storage of those blobs to object storage since they're never accessed anyways. And something else that's nice is at least on GCP, they have tiered object storage that, like the colder the storage is, the cheaper it is. And it gets moved automatically to colder and colder storage based on access patterns. So that can end up saving us storage costs as well.
And just to clarify, this is transparent to the client. So this is something that server admins on a self-managed instance or us on GitLab.com, we could configure this however we deem useful. It runs during housekeeping. It offloads what we filter it to offload. And from a client perspective, if they go to access it in a year, it's still accessible. It's just offloaded and it may have a slight delay in downloading because if it's in super cold storage, it would take longer.
Yes. That is the goal. Right now, if you notice Eric's clone command, it does include some like he did have to pass in like the funky URL there. So our goal is to for this to be unnecessary to where the client doesn't have to pass in anything, any flags, any config settings. The server should be able to pass all that information to the client.
No, that's excellent. I understand this is a demo and we're just doing a proof of concept. This is excellent just to show the capabilities and show that this technology is, obviously with the proof of concept, we proved it's doable, which is excellent. So this is really fantastic. And I can really see this not only as a cost saving measure for server administrators or self-included on .com, but other, self-managed instances who have very, very large numbers and some older repositories that they may want to archive, but have them still exist. They don't really want to truly archive them by removing them. This does free up space, frees up the expensive storage, the fast storage that people are using all the time, and move some of the older projects off of that, or it frees up, to your point, LFS is sometimes cumbersome to configure. This has a lot of the same benefits of LFS without actually having to configure LFS on the fly and having developers learn the LFS configuration and how to pull and sync things with LFS. So there's a lot of advantages here for ease of use as well. This is excellent. Thank you so much for this demo. I really appreciate the work that's gone into this. There's a lot of potential here.
Yeah, Eric, I don't know if there's like network issues with GCP. It's like things are
Yes,
frozen.
probably, yes. It's
always happens during a demo, right?
It has been acting weird since this morning. So
that's okay. No, it's okay because we can see the concept, we can see the housekeeping, filtering things off to object storage, and then we can see the command being run and shows that we can still do the pull like we normally would. And understandably, network issues can always impact things, but functionally, this looks like an awesome proof of concept and something we can iterate toward. Obviously with the URL and things, iterating toward a very workable solution for our clients.
Awesome. I'll stop the recording.